Hello everyone, welcome back to my channel. Let's learn mathematics by understanding concepts of mathematics. Today's concept is decimal expansion of rational numbers. Before that, if you want to know about types of numbers, I made a separate video on types of numbers. That link I will give at I button as well as in description box. You can go there and check the link. Please see that video also. Let's get started for today. As I said, today's concept is decimal expansion of rational numbers, how to convert rational numbers into decimal form and which kind of decimals we will get by conversion of rational number to decimals, that we will understand by this video. When we convert rational numbers to decimal form, we can get two type of decimals. First type of decimal is terminating decimals. What is the meaning of terminating decimals? Let's understand by one example. One example I am taking as 9 by 4. As 9 by 4 is a rational number, we can convert 9 by 4 in decimal form by doing a division process. We need to divide numerator by denominator. In this example, numerator is 9 and denominator is 4. So we need to divide 9 by 4. And when we divide 9 by 4, then division will become as 4 to the 8. 9 minus 8 will become 1. 1 is smaller than 4. So we need to take one decimal point in a quotient and 1 0 in front of 1. Then 1 will convert in 10. 4 to the 8. 10 minus 8 is equals to 2. Then again 2 is smaller than 4. But if we took one's decimal point, no need to take again 1 0 we can take in front of 2. 2 will convert in 20 and 4 5s are 20. 20 minus 20 is equals to 0. 20 minus 20, our remainder become a 0. So after doing division process, decimal expansion of 9 by 4 will be 2.25 and remainder become a 0 after some steps. By observing this example, we can say that after some steps our remainder becomes 0. That indicates that division process is completed. That is mean division process is terminated and the quotient, which is 2.25, is the terminating decimal. That means we can say that terminating decimals are the decimals where remainder will become a 0 and division process will be completed. Rational numbers, when we convert in a decimal form, we can get another type of decimals also. That second type of decimals is non-terminating recurring decimals. Now, what is the meaning of non-terminating recurring decimals? Let's understand by one example. Here I wrote as case 1 because there are two conditions or two cases will be there. So first case we will understand by this video, by this example. So I took example as 7 by 3. As 7 by 3 is a rational number. Again, as per previous example, we can convert in decimal form by doing division process. So division will become as 3 to the 6. 7 minus 6 will become 1. Again, 1 is smaller than 3. So we need to take one decimal point and 1 0 in front of 1. So 1 will convert in 10. Now 3 3s are 9. 10 minus 9 will be 1. Again 1 is smaller than 3. But if we took one's decimal point, no need to take again decimal point. We can take a 1 0 in front of remainder and 1 will convert in 10. So 3 3s are 9. 10 minus 9 will 1. If we observe this example, here after some step, remainder is repeating and that is a non-zero number and quotient 2.33, in quotient 2.33 one number is repeating, that number is a 3. So we can say that in non-terminating recurring decimals, remainder will be a non-zero number and in quotient
one number will be repeating or one number will repeat. In this example, that repeating number is a 3. So that indicates that division process is not terminated, that is when division process is not completed, it will be a continuous process, and this repeating number we can write as 2.33 as so on, or we can give one bar on a repeating number, that is mean on top of a 3. So that is mean we say that non-terminating recurring decimals are the decimals where after some steps also remainder will not be a 0, and in quotient one number will be repeating again and again. A second case we will see by the second example. I am taking example as 13 by 11. Let's do the division for conversion in decimal form. When we divide 13 by 11, then it will come as 11 ones are 11, 13 minus 11, it will become a 2. 2 is smaller than 11, so one decimal point we will take. 2 will convert in 20. 11 ones are 11. 20 minus 11 become a 9. One more 0 we will take here. 11 8s are 88. 90 minus 88 will become a 2. One 0 we need to take, so it will convert in 20. 11 ones are 11. Again 9 is remaining. Here in third step remainder was 9, and here after 2 steps again remainder become a 9. That means after some steps remainder is repeating, which is a non-terminating remainder is a repeating, which is a non-zero number. And in quotient, in previous example one number was repeating, but in quotient here one group of number is repeating, and that group of number is a 18. So we can say that decimal expansion of 13 by 11 is 2.1818 and so on. That dot 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 indicates that and so on, that is mean it is a continuous process. Or we can show that recurring decimal as a bar on top of a repeating number or group of numbers. So we can write as 2.18 on top of a 18, we can write a bar. On top of 18 we can draw one bar. That indicates that 1818 is repeating again and again, and after some steps also our remainder is a non-zero number. So we can say that non-terminating recurring decimals are the decimals where remainder will not be a 0, and in quotient one number or group of numbers will be repeat. That indicates division process is a continuous process. So today we saw about decimal expansion of rational numbers. When we convert rational numbers in a decimal form, either we can get a terminating decimals or we can get a non-terminating recurring decimals. Non-terminating decimals means where remainder will become a 0 and division process will be completed, and non-terminating decimal means remainder never be 0 and number or group of numbers will be repeating in decimal expansion. So we can say that decimal expansion of rational numbers can be either terminating or non-terminating recurring decimals. Keep remember its converse is also true. What is the converse now? Converse is if decimals are terminating or non-terminating recurring decimals, then they are rational numbers.
That's all for today. Thank you.